LCM, we've actually gone through a lot what's already in the books. I realized...
You're so good.
Oh, Shawson, do we have that on tape? So we do. We actually did cover a lot of this already that are in all the chapters. They're a little obsolete. I mean, they don't even mention M plus in this book, but they're a few years old. They're still nice chapters. A couple things you need to be mindful about. Technically speaking, if you have ordinal items, which is going to happen in psychology, right? You know what I mean by ordinal, right? 5 or 7 points self-important. You probably aren't going to meet which assumption?
Normality?
Multivariate normality. Most people would say don't worry about it. If you have 5 or more data points to a scale, strongly agree to strongly disagree, you're okay. That being said, Liseral and M plus are equipped to handle these types of ordinal variables. If you really have ordinal items, and it's called a polychoric correlation matrix. It's a polychoric correlation matrix that uses different type of estimator. And I really don't know if Amos produces them. I don't think they do. But other software does produce polychoric correlation matrices, which is if you truly have ordinal items. Number 2, M plus has maximum likelihood robust, meaning robust to non-normality. So it even has an estimator that's already robust to non-normality. Now, what if all your items are dichotomous? What if all of them are dichotomous? Yes, no, yes, no, yes, no. No way can you assume multivariate normality. And again, there are categorical options in M+. Amos, I don't know how Amos handles dichotomous indicators. I don't know how they handle dichotomous indicators. But that being said, everybody, you can have dichotomous indicators for a mediator, dichotomous indicators for outcomes, for exogenous variables, and in M+. It's very interesting what it does. Let's say for now, let's make this really easy. Let's have a path analysis, a good old path analysis. And this is job performance, continuous measure. Job satisfaction, continuous measure. Smoke, non-smoke. Smoke or not smoke. The mediator. Does everybody see it's a binary mediator? Does everybody see? So, can't just do good old regression on all these because it's binary. So at least M+, I can't speak for Amos. M+, when you identify this as what's called categorical, it'll do a type of logistic regression. It'll do a logistic regression, or actually what's called probit regression. It'll do a probit regression here, and a good old multiple regression there, and a good old multiple regression there. But it will take into account the outcome here. The mediator is binary. So you can, indeed, have binary indicators, binary manifest variables. Amos, I don't know how Amos handles that. That I don't know. Yes?
What do you think is a good way to learn M+?
I think there's a few things. I think what's great, that's an excellent question. First of all, they have just an absolutely amazing discussion site on M+. All these topics, the mutanes who author it respond right away. The support they offer is, I mean, they're busy people. I always get an email. If I have something that I can't figure out from the discussion site, I will go ahead and email Linda, the support. She responds always within 24 hours. And so first of all, I use this as a learning tool. Also, the whole manual, 7.0, is on the web. You can just download it. The entire manual, M+ 7.0, is right here. The user's guide is right there. And Barbara Bird has a new book out in the past year on M+. And then to start to play around with data, they got tons of data sets. People, Sharon Foster loves the videos. All his training, if he doesn't handouts, are all on the web. I just don't have the time to look at them, but Sharon says they're fantastic. And Ben Mutane is a great teacher. He's done APA, and he's one of the best. And they're all on the web. So that way, M+ is amazing.
Is that the M+ website that you're on?
With the M+ site. So you can learn all that. As for the software, As for the software, as a student, I have no idea what type of rate they can give you. They probably can give you a student rate if you wanted to purchase it. And also, just so you know, you have what's called the M+ program, which does structure equation modeling. But I've also added 2 other elements, which I'm going to talk briefly about today. There's a multi-level modeling option and mixture modeling. So I have all 3. You may not need all 3, and it'll be cheaper. It will definitely be cheaper. Now, what's happened, and with students it might be different, but let's see if they have a student rate. Student pricing is available, if not yet obtained a PhD. Oh, you know what? The base program is $195. Not bad. Not bad. So, M+, there's not a graphic interface like Amos. It's all syntax. But the syntax is really, actually pretty easy. I mean, just showing you, just good old confirmatory factor analysis. The syntax is, for a basic model, here we go. The names of the variables. F1, first construct by Y1, Y3. F2, by Y4 to Y6. 2 lines of code. Some things you have to learn about. It's got to be an ASCII file. You've got to convert your SPSS file to ASCII. If you have missing data, you do have to code them as integers and use the missing data option. And that's what's great about M+. It uses full information maximum likelihood. But I mean, look, just even for CFA, what if they're all binary? What if they're all yes, no's? You just say categorical R. And it does these type of, it uses the tetrachoric correlation matrix. It converts it to tetrachorics. What if you have continuous and categorical? What if you have counts, like Poisson models? What if you want to do item response theory from your psychometrics class, 2-parameter logistic item, which I showed you last week in class? What if you have a second order factor analysis? Remember good old Spearman's G? Spearman's G, intelligence, goes into other factors, called the specific orders, and then they have items. That's second order factor analysis. That looks like this. What if this is general intelligence? That's spelling, math, etc. What if it's nonlinear, everybody? Then you can use this algorithm called integration. If you have nonlinear relationships. What if you have covariance, which Zach brought up earlier? X1, X2, 3. There you go. What if you want to control for sex, age, and number of years they've been on the job? What if you want to look at means? What if you want to compare means? What if you're interested in means? You can do that. And then structure equation modeling. So it's pretty cool. And it's got examples. All this stuff is right there on the web and in their manual. I think M+ is the best right now. It's just my opinion, but you can take it for whatever it's worth. I think M+ is the state of the art. I really do. Now, Stata has come up with a new SEM. Stata does have an SEM within its software, and there's a free one in R. There is a free program. R and SEM. And there's a package that's free, everybody, if you want to spend the time learning it. If you want to spend the time learning R, one of your colleagues has actually spent some time learning R. Takeshi, I think, has spent some time learning R. And, you know, it is very strongly a programming language. But it's free. You won't have to spend a penny. R does every single statistic under the moon. But you'd have to spend some time. But there's the REM, there's the SEM package. So that's that, everybody. So we've almost covered most of the topics in SEM. There's actually a lot more I could discuss, but you've got plenty to go off for your in-class presentation next week. Okay? I want to go ahead and do a few other things with the remaining time to go over essentially what will summarize the rest of them, almost all the other multivariate techniques, just so you know about them. So the following rest of the less than an hour will be just other techniques that are in the books, except I'm not going to do multidimensional scaling. Last week, a few of you were in the IRT. Not all of you were in psychometrics. So IRT is mentioned. We discussed item response theory already. But now let's discuss this thing called survival analysis, which is in this book. Has anyone ever heard of survival analysis? What's your understanding of it, Zach?
It's sort of, I don't know, it's like, kind of you're talking like last week about die or not die. Like it kind of looks at the situations of who persists in a, I don't really know much more about it than that.
Okay. Okay, but you are right. That you do have an event exactly like that. So let me see what. So here's a journal article that we haven't posted on the web, but Dr. Jaski's big honchos cardiologist in town, and then it's called a 20-year experience with urgent percutaneous cardiopulmonary bypass for salvage of potential survivors of refractory cardiovascular collapse. You know, that's their title. I mean, it's in the Journal of Thoracic and Cardiovascular Surgery. So, what Zach said, sometimes you have, let's call it an event. I'm going to call it an event. For now, let's do an IO example. Let's use it for if you leave or stay in the corporation. So, there's been a company that's been really concerned because they've been having lots of turnover. Lots of turnover. In fact, wow, 40% turnover. Does that seem like a lot? Let's say there's lots of turnover. Binary variable. Does everybody see stay or leave? So what if you're not interested in that as your outcome, which would be binary logistic or discriminant function analysis? What if time to the event was your ultimate interest? Okay, do you see what I'm saying? Time to the event. So I start my data collection on January 1st, 2012, and I end my data collection on December 31st, 2012. There's actually a fancy term for that called the fiduciary period. I have a 365 one-year data with a start and end date. Does everybody see what I said? Start and end date. Which means I want to know the probability people leave or stay given this time. So now survival analysis is equipped when time is the event to get a really nice idea about examining what's going on. And just so you know, it is in the book. They do have a chapter on survival analysis. Just so you know which chapter it's on, everybody, if you want to read it. It's the last chapter in the second book. It starts on page 363. So, survival analysis focuses on the time interval between two events or survival time. So let's look at a single sample. So, Stacy's really concerned about turnover. Do we all agree 40% turnover would seem kind of like a lot? Yeah. So this is data I made up before class, just for 30 individuals. Small company, just to give you an idea. Do you see I have stayers and leavers? Time, I start my data collection on the 1st of 2012 and end it. Let's assume there's 365 days. All the people that stayed are called censored cases. So it's also, as with this technique, there's kind of a new vocabulary to it, everybody. There's a new vocabulary with survival analysis. Now, you asked me, Stacy, how you learned SEM. How did I learn survival analysis? I was never taught this in school. I mean, this isn't a biostats program. So I bought a book. There's a couple major books on survival, and I dummied up some data. Whenever I learn a new technique, I dummy up some data. I go through the book, and hopefully the book even has a data set. I can see I got the right parameters, the estimates, and I can move on from there. So I had to learn survival analysis quite a few years ago on a project with Sharp Healthcare. Because in medicine, it's used a lot. It's used a lot. A censored case, what's called censoring, means Ross may have left. Is there a chance Ross may have left February of 2013? Absolutely. He may have left. But guess what? We stopped data collection December 31st. So he'll be considered a stayer, but he may have left. That's called a censored case. And there's all these words. There's even different type of censoring. There can be like lost to follow-up. Ross took off, we have no idea, or we didn't have the information. So now we have the censored cases. So you see I plugged in 365 days? Usually though, unfortunately, I would love it if my data came like this with a variable called time. I would love it. But usually what I get, everybody, is start date and end date. So I'll get 1/1/12, 10/11/12, and I have to compute it. I have to compute the days, the number of days. You can do that in SPSS, everybody. Have any of you ever played with the date function at all in SPSS? Have any of you experienced? Just so you're aware of it, everybody, because it's going to come up someday. If you go to your syntax reference guide, and you go, let's see where it's gone. Universals. Okay, let me find dates. Let me find this for you really quick here, everybody. Dates. There we go. Date and time 90, page 98. Page 98. There we go. So there's a whole section here, everybody. A whole section here called date and time functions. Okay? Just so you know, in the manual. Oops, that's a little too big. It's called date and time functions. And how to deal with dates. And you can convert them. You can convert things to days, hours, minutes. And there's all types of conversions. So if I take the difference, and I have to, it's syntax only, everybody. C time dot days. And if I take the difference, it'll return to me the number of days. There's all types of things you can extract. You can take, look at this, everybody, date differences. You can do date differences, date diff. So there's all types of things you can do with dates, if you ever get that in any of your research. So a lot of times I have to compute this. I love it when my client gives me this, but usually it's start date and end date. So here, everybody, we see that we've got these people that stayed for 1 full year, but look at this person. Zach left after 4 months, right? Here we see 156 days, Chad left. Ross left 98 days. Do you guys get an idea of the data setup? So minimally, this is all you need, those 2 variables. This is the minimum survival analysis. That's it, everybody. So, analyze. Then you go into survival. And let's hit life tables. I put time under time. And then you decide what intervals make sense. You're not going to do it by days, because that would be a huge output from 0 to 365 days. So it might be by months. You might do it 365 by 30 for a month, or by 7 if you want weeks. Let's say I want it by weeks. Let's go and just divide it by 7. And then you put your event, which is the main one. In biostatistics, if you're looking at live and die, it'd be dying. In our example, it'll be if you leave the company. And then I can get all these graphics, which I'm going to show you in a few minutes. And here, is this your first? Just curious, is this your first time you guys have ever seen a live table, the survival analysis?
Yeah.
Okay. So here's your interval in days: 0, 7, 14. I'm going to make it 30, you guys, and I'll tell you why. Just because it'll be easier for you to see in one graph. It'll just be a little bit easier. And I'm going to go and paste the syntax. So I'm going to put 365 by 30. This will just make it a little bit easier. Okay, everybody, start time, 0 to 30 days. Number withdrawing, 0. No one left the company. That's good. But let's find Oops, look what happens here. Between 60 and 90. See, starting at 60 and 90, Ross left the company. They say about your generation right now, they're saying the millennials are leaving companies pretty darn quick if they don't feel they're getting A, sufficiently challenging projects, and B, if they're not quickly promoted. Do you buy that? Mm-hmm. Do you really, or is that just a glib generalization? And I read that in Money Magazine. They said, this generation expects challenging projects kind of early on. What? Oh, the past one?
Behind me.
Behind you.
So-
Do you guys buy that, though?
Yeah.
Really, why? I mean, is that really a true phenomenon, or is it just kind of a...
It's a pretty selfish, self-indulgent generation. Everyone's posting what they're having for dinner on Facebook, and everything's the world, it revolves around them with tweeting and all that crap. So I feel like it's they've through a lot of things been kind of trained to think that they're the most important thing. I think it's a selfishness, like self-indulgent kind of thing.
So Zach, you go work at Nordstrom's. They're not going to make you HR VP right away. You're going to probably be folding shirts and sweeping and doing.
What?
You're going to be.
Maybe not sweeping, but
There's like a certain sense of entitlement, and I think part of it is that there's no trauma that they've endured.
Okay, so Ross expected to be VP in 2 weeks.
Pretty much.
So he left. Do you see this? Number of terminal events, proportion terminating. Up to this point, there were 30 people. 1 out of 30 is about 0.03. Then you get proportion surviving. So you see why that's why lots of people associate this statistical technique with living or dying. But it's just the terminology. People staying in the company. Hopefully you're not dying at Qualcomm, right? So hopefully, so in other words, 97% have stayed, and then you get this. You get. It's too low. You get this thing called a hazard rate. What is a hazard rate, everybody? A hazard rate, which usually would have numbers, but it's such a small sample size, it usually would be the probability that you drop out in that interval, given that you've survived to that time. The probability that this cohort has stayed in the company to 90 days, and now the probability you're going to drop out. That's called the hazard rate. That's called the hazard. So look here, everybody. Wow, look, we see that 3 people dropped out between 120 and 150 days. Look, 11% of people, given the number of people that are in the company up to that time, you can see that 11% terminated. And then you can see the proportion surviving, and you get a hazard rate. Now, you got from 30 people to 29 to 26, so you get different probabilities associated with the prior stage and the current. So do you see what survival analysis is taking into account? Taking into account this. Here's your survival function. Here's your survival. It usually is this type of step function that usually decelerates. Sometimes it can be pretty severe. Cardiac arrest in the first 30 days. A lot of times it happens. Bad shit happens in an early time. A lot of times you see a really severe step function, then a little trickling. So look here, everybody. You can see stuff really starts to happen about, after about 100 days. And then it kind of levels off after 300. So that's called the survival function, everybody. And you get 1 minus the survival, which are the people that stay. And you can get an idea of the hazard function. The hazard, again, is the probability that you're going to drop out, the probability that Zach is going to leave, given that he has stayed at the company up to 6 months. So it's a very different language, isn't it? But do you see where it's really cool that you could see where this would be really valuable in psychologically related research? Not just medicine, not just biology, but anything where you're interested in time to an event. So that is basically life tables, everybody. And now, what if? What if, everybody, I add sex? Okay? I'm going to add 0 will be males. 0 will be males. 1 will be females. So now I have a binary variable, everybody. I have a binary variable called males and females. Now you can move on, survival, to this Kaplan-Meier test, the KM, used a lot in epidemiology medicine. So I have my event, bless you, event, defined event will be 1. That'll be for those that leave the company. Time is still time. And now I have a factor called sex. I have a factor called sex. I'm going to use these 3 tests of significance. So now what you can do is compare the survival rates of males and females at Qualcomm. Because that may be of interest. Here you see we have 15 of each. 4 males have left the company. 9 females have left the company. Does everybody see that, everybody? 4 have left the company. 9 have left. The other cases are called censored. Ross may have left the company in January 2013, but we stopped our collection at that time. We stopped our collection because you have to have an end date. Sometimes you have to have an end date. And here, everybody, you get a survival table for both groups. You get a survival table for both groups, and we can see that, this male lifted 87. There's Ross. He didn't get promoted. 87 days, right, Ross? You're out of there. 90 days, and you're gone. And there, I can see that there's 14 remaining cases, and you get a test of significance, everybody. It gives you the estimate, 306 days for males, 260 for females. Females, you're leaving quicker. How come? Wow, females. You're leaving 46 days earlier on the average. How come? You may want to see what's going on there. And the test, there's 3 tests of significance. Most use the log rank. The P is 0.097. So you are happy it's not significant. But let's pretend it was 0.043. Something's going on, huh? Maybe there's some harassment. Who knows what's going on? But do you see where you could use this to compare males and females? Look in survival. You could totally use this in organization psychology research.
0.097?
What's the 0.097?
0.09.
0.097. You got it. And here's the survival functions for males and females. For males and females. And you can tend to see at 260 days, you know what? You just got more females. They're saying, I'm out of here. Males are tending to stay. Ross is the outlier.
And where they plateau is the end of the study.
Yeah, instead. Right, it stops at 365 days. Because that's the end of my data collection. So that's the Kaplan-Meier. The Kaplan-Meier. And you can compare hazard functions, which are the probability you've stayed in the company up to that point. So there's a lot of really cool things you can examine where time is the event. And to take this one step further, everybody, if I go to survival, there's a thing called Cox Regression. Time goes here. Status will be the event. Put in a 1 here. And what if you want to add a predictor? What if you want to do a predictor? And I put job performance under covariance. Cox regression is a regression model where time to the event is the outcome. It's literally the DV. And you can add time varying or time invariant covariance. Time varying means what if I measure job performance every single day you're on the job? Or here, everybody. Here, as I've set up the data, I've got individuals. Look if I have job performance measured right there, which might be time varying. Guess what time invariant is? Sex, unless you had a surgery. Right? Sex would be time invariant. Performance might be time variant. So here, everybody, you get -2 log likelihood. Sure looks like logistic regression. And the model looks very similar to logistic regression. Why? It's got a B, which is kind of like a logit, and it's got this exponentiate B of 0.722. And I guarantee if you take a log of 0.722, it gives me a negative 0.33. So what that means, that negative relation means the higher the performance, the less likelihood you're going to lead. Right, the negative relationship. However, technically it's not really an odds ratio, it's what's called a hazard ratio. It really is called the hazard ratio. So here what I just want to show you, everybody, very similar to logistic regression, you can go ahead and do what's called Cox regression, with or without time-varying covariance. With or without. So that is your Reader's Digest exposure. It's probably a technique you haven't heard about, called survival analysis, the Kaplan-Meier, the Cox regression. If you go to medical journals, the premier medical journal is called Statistics in Medicine, and it's always got very sophisticated articles on survival analysis. So that, everybody, I want you to at least be aware of that technique. The time is the event. Any questions on that, on survival analysis? Any questions on that? Okay, excellent. Okay, now, on to another multivariate technique. Jocelyn is on a project at Center for Creative Leadership, looking at some of these interpersonal constructs. Relationship, interpersonal, social support. And she thinks to herself, I wonder if this set of variables result in any unknown homogeneous groups. I wonder if the combination of these variables culminates in any unknown groups. So then, how many of you have ever heard of cluster analysis? Used a lot in which field? Do you know, Stacy, what field it's used a lot in? Marketing research. So it's interesting, you see some of these techniques, such as conjoint analysis, marketing research, used a lot in decision sciences, marketing. They could be used in other areas. Survival analysis, you tend to associate with biostatistics. There's no reason why it's not used. Cluster analysis is a technique of which the group variable is what? Known or unknown? Unknown. With discriminant analysis and logistic, it was what? Known. Here, what if it's unknown? Is there a chance that, how many of you like to drink beer? What goes into buying a beer? Does it matter if it's domestic or import? Does it matter if it's cheap versus expensive? What else? What other dimensions go into the purchasing of beer? So we got price, we got, domestic versus import. What else goes into the purchasing of beer?
Type.
Okay, type, meaning keep it a little more
Style,
specific.
Like a Pilsner or a lager.
Okay, type like that. I guess from what I've been hearing or read in the newspaper, it was actually in the LA Times, I guess San Diego's become the big brewing capital. Microbrewing or something. Yeah, there's
like number one in the nation.
It is.
Usually between that and like Port Rouge.
Great, we're the crystal meth capital and beer. Wonderful. So, maybe microbrewing. What else goes into buying a beer?
It goes into buying a beer?
Yeah, what decisions? What other factors? What attributes go into?
If you're going to be driving or not?
Well, no, I'm not talking about that. No, I'm talking about the beer, the purchase of the beer, the attributes of the beer that guide your decision to buy the type of beer. Not whether you're
alcohol
drinking it.
content.
Okay, do they vary?
Yes.
I once, back in the 80s, I don't drink for many, many years. My brother and I went to London and we drank a beer from the spout called Guinness in a little pub. It was warm and strong. I mean, the Guinness, I know, had more alcohol percentage. So what if, can I get a certain type of person that buys import, Pilsner, expensive, versus cheap, domestic? For instance, when I was in college in the 70s, we used to buy Lucky. You got 24 for $1.99, 24 beers, had little puzzles on the top once you twist it off, which we would try to figure out after a few of these. What type of person would tend to buy that? A fancy schmancy lawyer in La Jolla, or some student who's barely making it? So, cluster analysis can be used in market research to say, what are certain attributes that segments, and that's why sometimes they're called segmentation studies. What are certain segments by. So that's why they may take your zip code when you used to check out. I don't know if they do that anymore, but guess why they're getting your zip code when you check out? Why are they getting your zip code?
So they can see who's buying what where.
Who's buying what where? Is there a chance that maybe Lakeside versus Ramona versus Del Mar versus La Jolla versus PB might have different types of profiles? So what's really cool about cluster analysis is the ability to be able to find these unknown homogeneous groups based on a constellation or a linear combination of variables. So, relationship, interpersonal, and social support. There's a lot of decisions that go into cluster analysis, everybody. A lot of decisions. When you go to classify, there's what's called two-step cluster, k-means cluster, hierarchical cluster. 3 major techniques. One minimizes by sum of squares. One is called hierarchical. What is hierarchical cluster? So first of all, you have to decide if you're going to use hierarchical or non-hierarchical. What the heck does that mean? I have 600 individuals, 600 beer-buying patrons. Hierarchical versus non-hierarchical. One would do what's called an agglomerative. I'm going to pretend I got 600 different clusters for 600 people. And then I go through hierarchical to what? Pare it down to a couple. Non-hierarchical, you start with just one, and then you split, assigning them to groups. So you have to decide on the type of method. Number 2, the type of distance you're going to use. Ultimately, part of the mathematics is what's called distance. What the heck does it mean by distance? Well, the simplest one is thinking what the variance was, right? So maybe a 3 minus 2 squared. That's called Euclidean distance. So Euclidean distance is one way of getting at the distance between 2 data points and see if they are distant or not. That's why you have a whole vocabulary called similarity matrices, dissimilarity matrices, all types of distance formulas. So if I put my 3 scales in, everybody, put in all 3 there, statistics, proximity matrix, cluster membership. Let's go ahead and let's say it can range from 1 to 5 clusters for now. Okay, let's just do none for now. Method, everybody. Look at all these options. Euclidean distance, squared Euclidean distance, cosine, correlation. This is what's called the city block. So you've got all these different types of distance matrices. Let's just use the default for now. Okay, we'll use that for now. And then, it's sometimes a nice idea to transform your measures if they're not the same metric. Why? What if one variable is how many beers you buy a month, and one variable is cost? Those are very different metrics. And they're going to have different, distance is sensitive to metrics. So sometimes it's not a bad idea to rescale. I don't need to do it for this because they're all the same metrics. But you can standardize it right there. You can standardize to z-scores by variable if you want. Plots, all clusters. And for these 200 people, everybody, I do want to warn you, the hierarchical can take a really long time if you have a large sample size. It can be very slow. This one went okay, but it can be very slow. So look, everybody, it returned a 2-cluster solution. It returned a 2-cluster solution. And if you wanted to, everybody, analyze, classify, hierarchical, you can go and save for 2 clusters. Okay, look what we get, everybody. You get this variable right here. It's the group membership, and it might be interesting to compare the means on those 3 variables that I put in compared to the cluster. And you can see, I'm not going to do this now, but you can actually, oh, I'm sorry, I did the wrong thing here. Hold on, you guys. So let's go ahead and put in my 3 scales under dependent, average linkage there. And there you go, everybody. Here's my clusters. I've got 198 in one cluster, 2 in the other. I'm not happy with that. You can see that they're really high here, really low there. But you know what? I would not be happy with this solution. For 2 people in a cluster, I wouldn't be very happy. And I know why. I don't think there's a lot of variability. So let's look at another option, everybody. Let's use 2-step cluster. You can put in continuous or categorical variables. So very flexible. We're going to standardize 3 variables, add options. This is good as we have it. Actually, you know what the one I want to use? I'm going to use k-means. Let's go ahead and use k-means option. That just gives you a visual. Let's put in my 3 variables here. Let's have 2 clusters for now. And options, ANOVA, cluster information for each case. We get 2 clusters. And cluster 1 has 63 people, 137 in the other. And look at the means, everybody. Cluster 1 has lower mean, lower, lower. This one has higher on all of those variables. So you have 2 distinct clusters that are unknown. So what's really cool about cluster analysis is the ability to find these unknown groups that you may not even be aware of. See, we're assuming you've got this one nice normal distribution of a homogeneous group. But you know what? What if there's 2 distributions embedded? So cluster analysis is a valuable tool. It's a valuable tool for being able to examine these unknown groups. So that's just a little brief blurb on cluster analysis and very closely related is what's called finite mixture models. This is something I would love to see some Alliant students start to get a bead on. Finite mixture modeling is kind of a kissing cousin to cluster analysis. What if there's what's called latent classes or latent groups? They're unknown. And here, maybe there's 2 distributions embedded in one. So you got a host of variables, and you want to see these different type of mixtures of groups. So, finite mixture models have received increasing attention in a range of fields from astronomy to biology, genetics, medicine, psychiatry, economics, engineering, to the point, what if I have psychological well-being? Is there a chance that those who say yes and those who have no, that maybe they have different distributions? So, mixture models. It's important to understand the relationship of the latent and manifest variable. Exploratory factor analysis assumes the latent variable is continuous and the measured. What if the latent variable is continuous and the manifest is categorical? That's IRT. Latent trait analysis is item response theory. The item is true, false, and the trait is continuous. What if you have a categorical manifest variable and a categorical latent construct? Which means you're in group 1 or group 2, and the items are yes, no, yes, no. That's called latent class analysis. And what if you have a latent class? A latent class. Thinking of a latent variable, and it's categorical. So there's my latent class, everybody. And maybe I've got multiple items that are yes, no, yes, no. But my construct is not like job set, it's actually a latent class. Then you've got the beauty of finite mixture modeling to be able to use it. So, how do you do this? Not in SPSS, unfortunately. I'm sure someday they'll have that option, but they don't now. One of the premier softwares, everybody, that was, I think it may have been I don't know if it was the first one, but it was definitely an older one. It's called Latent Gold. Latent Gold, yes, it's 1995, so it's been around. And it published a latent class of finite mixture models and any other class statistical models. Latent classes are unobservable subgroups or segments. Classes within the same latent class are homogeneous in certain criteria. So it sounds like cluster analysis, doesn't it? It sounds very similar to cluster analysis. But you're going to see the differences in a few minutes. So what if I have somatization, anxiety, depression, pain scale, and fatigue? This was someone's dissertation at USD School of Nursing that I helped with. And right now, I met them last week because they're going to try to publish it. The committee had no idea about this technique. They were absolutely lost. They never heard of mixture modeling. And I have no idea how many faculty here know about finite mixture modeling. I have no idea. I know Sharon Foster does. I know Sharon does. So look at this, everybody. I have two classes. One with really high means that are actually in pretty poor psychological health, and one that is low. And you get what's called posterior probabilities. What we see is 64 people are in one group, which is the really kind of the group with high scores, and 458. So this is M plus, everybody. And I just use the code, classes equals C2. So what's cool is you can define your model. You tell it how many mixtures you want to test. So if you have dichotomous variables, everybody, like are you sad, generally sad, yes or no? Do you drink, yes or no? You can go ahead and do latent class analysis where we see 62% of people said they are not sad, 37% are. 79% of people said they're not down, 21% are. And you can try to make sense of these two different classes. What's cool about finite mixture modeling, you can test models. What if I want to make it, what if Stace says, I think there's a third class there that is a combination of sadness and non-anxious. And you may get that type of third class. And you can see if the model fits better with the third class. So that, everybody, is just a brief thing on latent class and latent profile analysis. Latent class is when you have dichotomous indicators, latent profile continuous. All of these have to do with classification. Classification of unknown groups. So now, that pretty much covers almost every multivariate technique. I don't have much time to get into this. You saw part of this lecture already on multi-level modeling. Multi-level modeling is something more and more people need to get into. Just last week, Ashley defended her proposal. She's going to be using multi-level mediation. The days of ignoring levels of nesting are pretty much gone, everybody. If you have pupil nested within class, nested within school, employee nested within department, nested within organization, if you have occasion, time is nested within participant, repeated measures, all of those have a violation of which assumption? Yes, independence. And you can't ignore that, everybody. You can't ignore that violation. So now with multi-level modeling, you can expressly model the variance components at each level. At each level. In other words, we know that if you don't capture the hierarchical problem, it can impact type 1 or type 2 error. It can result in what's called an ecological or atomistic fallacy. Ecological is drawing inferences about individuals from group level data. The other is drawing inferences about the group from individual. Both of those are types of fallacies. So here with multi-level modeling, I can simultaneously take into account what Zach just said, violation of independence. And independence can be violated based on groups, sequence, or space. What do I mean by groups? 10 people in HR that work in HR, 10 that work in finance, 15 that work in manufacturing. Are there a chance that if I gave a leadership inventory, people within groups might be more homogeneous within group and heterogeneous between? Absolutely. Which means you can expressly model that with multi-level modeling. Again, this is a 2-day workshop, 189 slides I did from the Center for Disease Control. I know I've had this available in 6021 or 6022, and I think I still have it on the web, so please have fun looking at it. But the objectives is to be able to capture this stuff. The variance components are basically the fact that each individual deviates from their group. That's the error, just like ANOVA. But then, what if I use job satisfaction to predict job performance? Might there be HR differences versus finance versus manufacturing? So you can capture not only the differences in intercepts, but what else can I capture? Differences in intercepts and differences in what? Slopes. In your psychometric class, you probably talked about test bias, and you can test for intercept bias and slope bias as a form of bias. Well, here, that's the intercept bias and slope, which means we can capture inter-cluster variability. And you get what looks like regression. Because if I have 6,000 employees nested within 50 companies, I end up with 50 slopes and 50 intercepts, which become outcomes. They actually literally become DV. Because you have levels. Level 1 is employee, level 2 is organization. And you're taking into account that clustering effect. Now, which statistic kind of shows you that you have a clustering effect? Is this thing called the intra-class correlation. The intra-class is used a lot in psychometrics. When you have maybe multiple people measured on multiple items over multiple times. Lots of uses of the ICC, but it basically captures the fact that, you know what, I may have 10 people nested within multiple clusters, and you can get what's called a design effect. How much the variance is inflated when you lack random sampling. So, multi-level modeling gives me the ability to break down variances and to take the variance in the error and the intercepts divided by the level 1 error and compute in ICC. What does that 18% mean? It means if my DV is mathematic achievement among 160 schools, it means 18% of the variability is due to between school differences. So, what you see here, everybody, using HLM, which is one of the softwares, I've got 160 schools, 7,185 students. See, if you didn't know about multi-level modeling, you'd have to make a decision. Is your effective sample size going to be 160 schools? And you lose information about what? If I analyze at the school level, what do I lose information about? Intra-school variability. If I use 7,185 as my unit analysis, I lose information about what? Schools. So what's cool is you can simultaneously incorporate information. So if someday you decide you're going to do archival research for your dissertation, and you inherited a data set from Center for Creative Leadership, and it's got 400 companies, 50,000 individuals, and you analyze with individual level data, and then you happen to get me as a third or fourth or a fifth or a 90th on your committee, and you are defending there, and you did not embrace multi-level modeling. You've got some fun analysis there. Say, Chad, are you absolutely convinced there's no inter-organizational differences? And Chad's going to have to say, I don't know, Dale, but I will learn multi-level modeling and test that. Right? So, multi-level modeling, everybody, is something that when I started consulting my own practice 9 years ago, I knew about it back in the 90s. I did it for one project. I had no idea what I was doing. It was Sharp Healthcare looking at, do you think when physicians are nested within hospitals, different hospitals might have different practice patterns? Could there be different practice patterns? Do you think possibly Scripps Memorial might be different than Sharp Healthcare on some things? So I was actually looking at that type of analysis, and I knew about multi-level modeling. I had no idea how to do it or use it. So it was a DOS-based program, kind of kludgy, you had a program, and I was dangerous with it. So that's my first exposure back in the 90s. Then when I started my consulting firm 9 years ago, I saw so many practical applications. When I'd see all these nested type of designs. And I knew it from my NOVA books. I taught nesting and I taught random factors from 6021. But finally I self-taught myself multi-level modeling, bought all the books, started learning it, and I've used it on many, many projects since then. I even ended up, just if you're all interested, this may be of interest or just bore the living heck out of you. But just showing you the application of multi-level modeling in longitudinal designs. A while ago, I was asked to consult with the VA and UCSD Department of Psychiatry, and it's called The Effect of Cross-Training with Adjustable Airway Model Anatomies on Laryngoscopy Skill Transfer. Basically, I think I told you the story already. I told you the story about that thing, right, going down someone's mouth, right, and me being not very good at it. Well, they were using these dummies for medical residences. They were using these dummies for medical residences, and the editor was really interested in the statistical technique because they hadn't seen it used in their journal of anesthesiology. So I just did a basic introduction to multi-level modeling for anesthesiologists. That was written in a kind of one of the premier journals for anesthesiologists. The application of this is as apps for longitudinal designs, for cross-sectional, for even combinations of nonlinear models, Poisson, count variables, dyadic analysis, wife's marital satisfaction, husbands. I've told more than a few MFC students here that haven't liked what they've heard. They were just going to correlate mom and dad. Because guess what? Is there a chance mom and dad are non-independent in a marital satisfaction survey? You've got to take, and that's called dyadic analysis. And you can even do multi-level mixture. What if you have multiple unknown groups nested within organizations? You can do multi-level mixture modeling, and you can use multi-level modeling to take into account inter-individual differences. Stacy is different than Chad, is different than Ross, and each one has their own different trajectories. Some go down over time, some go over when. I would say the biggest advances are the uses of multi-level models for longitudinal designs. What you learn in 6021 with repeated measures is fine. If you have no missing data, and it's pretty simple, fine. But the ability to model longitudinal models with multi-level modeling is absolutely amazing. Why? Because you can have any ranging from 1 to all the set of data and be incorporated in the model. If this person missed wave 2, guess what? Repeated measures, they're gone. They're out. Multi-level modeling will use all the data for all the people. It'll use all the data for all the people. So it's extremely flexible in that regard. Plus, it's kind of a long presentation. Plus, you can code time differently. Repeated measures assumes equal interval, right? You don't even put in time. It assumes 0, 1, 2. 0, 1, 2, 0, 1, 2. But what if you want to code? What if you want to make age 15 years old as the intercept? Right? Or what if you want to put in their specific age? Their actual age, because maybe they had in the survey at different times. So, it's extremely flexible to the point you can combine it with structure equation modeling. You can take what's called a growth curve model approach, where one latent construct is the intercept, the variance components where it's set to 1, and this is the linear 0, 1, 2 slope. So what's really cool is what if you have latent variables, and they're nested within multiple groups? You can look at this as a growth curve model or a structure equation model. And you can add mediators. You know, like I'm looking at an article right now, everybody, because a couple people are going to be using this approach. Ashley's going to be one of them, and someone from the CSPB testing multi-level mediation using hierarchical linear models. So it's amazing what you can do with the combination of many of these advanced multivariate techniques. That concludes my lecture for the day and the semester, and last time you ever have to listen to me. Thank you very much.